Hello and welcome to this section of the Physics 3 tutor. In this section we're going to kind of apply what we've learned in the last few sections on finding out what the force is on a wire that's carrying an electric current in a magnetic field, and we're going to apply that to something that every one of you has experience with, and that is basically the concept of an electric motor. If you slice open an electric motor, or if you go on the web and look at pictures of the inside of a motor, you're pretty much going to find two things in every single electric motor that you see. You're going to find permanent magnets inside that motor, and you're also going to find coils of wire. So the electricity goes into that motor, current circulates in the wires in there and the coils in there, and there's also permanent magnets fixed inside the housing of all of these motors, and somehow through the magic of science and engineering this causes the motor to turn. So all we know from the outside is we put electricity in and then a shaft begins to spin, and that's pretty much how every electric motor works. What we're going to do in this section is kind of pick apart that and learn how coils of wire can cause, forces to arise that are going to basically want to cause these things to rotate. So it's basically the fundamental theory behind how a basic motor works. And it's not too hard to understand that it might actually work out this way, because we've already established that if you have a magnetic field and you have a wire in a field and you run an electric current through that wire, that a force will push that wire in a certain direction. And we also did an example before where we had a curved piece of wire and we saw what the force was here. What we want to do here is figure out, is there a way to take a coil or a loop of wire, so instead of just a straight wire, it's actually going to be some sort of loop that comes back around. What will happen if we put a loop, some kind of a loop that's carrying electric current inside the field? And I'll just tell you the punchline. The punchline is that loop is going to want to rotate. It's not going to want to move left or right or up or down. It's going to want to actually rotate about some axis. And if you construct it correctly, and if you wind a bunch of loops, which is a coil, on top of one another, right, a bunch of little turns, then you will get the thing that wants to rotate very rapidly. That's what we call a motor. So that's the punchline, so what we want to do is sort of investigate that and figure out how it works. So the first problem, so to speak, is we're going to actually derive the torque on a current loop. I could just give it to you, but it's so important and it's such a great application of how we can use these things in real life that I think it's important for us to actually just sort of dive into it. So let me first begin by drawing, or trying to draw, a basic loop on the board. All right, so here's going to be my first stab at drawing one of these things, and you have to use your imagination a little bit, because I'm trying to draw it sort of three-dimensionally, because these coils are basically three-dimensional animals. They're going to rotate, so you have to give it some depth to kind of understand what you're looking at. What you're looking at here is a flat coil, or I shouldn't say a coil, a single loop of wire. You can kind of imagine it being this rectangular thing. It's in the shape of like this rectangular piece of paper like this, and it's kind of, sitting sort of obliquely here, and you can sort of see that there. And we'll just do a quick, some quick labeling, because we'll use these labels later. We'll call this side A. We'll call this also side A. What I mean by side A is this has a length A and this has a length A. This guy, we'll say, has a length B. This guy has a length B, so we know it's rectangular. One thing we're also going to draw, and we'll see why. Let me take this off for just a second. We'll see why here in just a second. We're going to draw a vector from the center of this loop kind of up like this, and this is 90 degrees